Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. Friends, today's video is the part 5 of the Thermodynamics class 11. So let's start this video. In this video, we will study about the work as pressure and volume, or we can say the relationship between the work, pressure and volume. So earlier we studied that internal energy can be changed by the work and by the heat. Now to elaborate that thing, we are going to study only the work when it is a mechanical work. So we will study here basically the mechanical work. Okay, and that will be done on the system. Okay. So we are going to see mechanical work done on the system. Then in that case, how pressure and volume are related to the work. Clear up? This is our aim. Now, suppose we have a system. In thermodynamical term, it is a system. In general word, I can say it is a container in which there is a piston. So this is our piston. Okay, so in this system, it is filled with 1 mole of ideal gas. Okay, now understand, it is a 1 mole of ideal gas. And because we are going to study about work done on the system, it means pressure, external pressure, we are going to put on the piston so that the piston will move inward. Okay. Now what will happen when piston will move? Again, say what will be the final stage? The piston will move till here. Okay. So this is P external. And this is the final volume. This is the V initial and this is V final, we can say. Now, can you see? The piston has moved. So what is the distance it moved? It is L. The piston moved L distance. Okay, so we can mention here distance is equal to L. Now next thing, we can see easily that there is a change in volume. So mention that also. Change in volume. We can mention it as delta V. And it is mentioned clearly here, it should be volume is equal to the distance into area of the cross section of the system. Okay, that will be our volume. Now we can mention it like that, volume is equal to length or distance into area covered. Now this also we mention as V final minus V initial. Volume, final volume minus initial volume. Now this is the change in volume. Now one more thing we knew, that in class 8 we studied that pressure is equal to the force per unit area. Okay, this we studied. So here the pressure external, obviously we are talking about external pressure, that is equal to the force which applied, which is divided by area, per unit area. Now come up to the work. When the work done on the system by moving the piston, the work will be equal to force into the length, force into the distance, not length. Correct? We mention it here. We already studied this thing in the lower classes. W is equal to F into distance, or L we can say, normal language. Now L is here. So in place of we can say here F is equal to P into A. Here P is external. From this expression we got this force. So can we apply this here? W is equal to, in place of F, we can put P external into area and distance is L. Okay, we can write like this. Simply yes, we can write. And again W is equal to P external. Now L into A, we studied that it is a delta V, change in volume. Clear up? So now we are nearby to relate work with pressure and volume. Yes, but there is something we have to work on. So here we get W is equal to P external into delta V. But see clearly, delta V here, final volume is less and initial volume is more. So when we do V final minus V initial, it means the delta V value will be negative. Correct? Yes. Or we can say, in other words, if something is decreasing, it means we should take it in the negative form. So here in this equation, delta V always be in negative form. So what if W, what about W? W also be negative if the delta V is negative. But here work is done on the system. Work done on the system. It means it should be positive, because when work is done on the system, the energy will increase, and so that we will take work as positive. Now we studied this earlier. Okay. So what we should do, what change we need to do in this equation so that W will be positive. The only thing what we can do is, we can write W, we'll put a negative sign here, P external into delta V. Now that expression will give us the positive work, because delta V always be negative, and negative into negative will become positive, and in this way we will get W as a positive because work is done on the system. And remember one thing, when work is done on the system, it means it is always compression of gas. So sometimes they won't tell directly in the question that work is done on the system. They will tell that compression happens. So if they use this word, you should be clear that work is done on the system by the compression of the gas. Okay. Now this is for the compression of gas. Now what if there will be expansion of gas? What will happen? Expansion of gas means work is done by the system. Clear? When work is done by the system, it means the gas itself, whatever is inside, it is pushing the piston outside. Okay, so in this case, work is done by the system. Now we can say expansion of gas. What is happening here? Work is done by the system. And if work is done by the system, it should be negative sign, because when work is done by the system, the energy will decrease, and so W will be negative. We studied earlier. Okay, now here in this equation, we want W negative. Now what we will do here? Again, so work is done by the system should be negative in the last, and see delta V. What about delta V? Delta V now from less to more. Okay, it was here in the initial state, V initial is less, V final is more. So from V final to V initial, it will be positive now. So delta V in the expansion of gas, delta V change in volume will be positive. So in that case, again we have the same equation that will fulfill all the cases. See here clearly, if delta V is positive and positive plus negative, here in this case itself we get the work in negative. So friends, both the equations same equation will apply for both the cases, for compression of gas, for expansion of gas. And one more thing that I am going to point here, this process that we put external pressure and we change the volume, that happened in one shot process. And this one shot process means sudden process. This sudden process is also called as, we studied earlier, this is also called as irreversible process. So we studied earlier irreversible process, that is fast and that which will not be reversed. So friends, in this video we are going to finish till here. In the next video we will study work, pressure, volume in reversible process, just opposite of the irreversible. Till then, do like, share and subscribe the channel. Don't forget to press the bell icon. Till then, thank you. Bye.